Okay, so this is going to be a run through of the June 2016 AQA Paper 2 Foundation level. So let's get started. Basically, the first question talks about circle the multiple of 9. Well, what we need to remember about multiples is it means the times tables. So we're looking for something in the 9 times table. So we go through here and we can see that this one is 4 times 9. So therefore this is the multiple of 9. All the others are not in the 9 times table. Circle the factor of 76. Well, we need to remember that a factor goes into other numbers, other whole numbers, and is a whole number itself. And factors have to be less than the number you're talking about or equal to it. So we're looking for numbers that are less than 76 or equal to 76 but go into 76. So if we look through, we think about the times tables. 76 is not in the 6 times table. 76 is not in the 8 times table, so it can't be that one, can't be that one. 76 in the 24 times table. Well, 24 times table goes 24, 48, 72. Now, as a factor has to be less than the number or equal to it, then the only one left is 40. And we can see that 20 times 4 is 80, and if we subtract 4, we get 76. So it must be in the multiple of 4, and hence 4 is a factor of 76. Okay, so we got to circle the cube number, and we've got to remember that cube numbers have a special meaning. When you multiply an integer, a whole number, by itself and by itself again, then that creates a cube number. So 2 cubed is going to give us 8, and 8 is the cube number. So if we go through, and we can see that 1 times 1 times 1 produces 1, so 1 is a cube number, 8 is a cube number from 2 times 2 times 2, 27 is a cube number from 3 times 3 times 3, and if we look through straight away we can see that none of these are going to be cube numbers. 81, well, we could do 3 times 3 times 3 times 3, which is 81, but then we've done it 4 times. That would be 3 to the power of 4, so not a cube number. So that can't be right. So the only one left to try is 1000, and then if we look carefully, 1000 is made by doing 10 cubed. So 10 times 10 times 10 gives us 1000, so 1000 is the cube number. So it says circle it, so we're going to circle that one. Okay, so that's a quick reminder of multiples, factors and cube numbers. Going to go on to a little bit of probability now, and we've got this question that's talking about, we've got 1, 2, 3, 4, 5, 6, so we know all the probabilities are going to be out of 6, or the chance of things happening are going to be out of 6. So we've got to use these probability words to fill in the answer that they are asking. So they're asking, what's the chance or the probability of picking the letter T? Well, we can see that there's 1, 2, 3 T's, so we're talking 3 out of 6 for the probability of picking a T, which is a half. And so in terms of the words that they want, then from here a half is evens. What we need to remember is there's a probability scale going from 0 to 1, where 0 is impossible, 1 is certain, and in between halfway through is evens, so equally likely. And then unlikely is down here somewhere, and likely is somewhere in there. It says what's the chance or probability that a card has a letter W on it? Well, we can see in here there are no W's at all, so therefore the chance of that happening is 0, which means that it's going to be impossible. So the word they want you to use here is impossible. So the question goes on and tells you that there are now 7 blank cards, so our probabilities are going to be something out of 7, and it asks us to write a letter on each card so that when picking one at random that B is likely, but it's also given us another condition that we need to take account of, and it's saying that D has twice the chance of being picked as C. So D has twice the chance of being picked as C. Now, because we're talking about things out of 7, then if B is likely, then we need to be past halfway. So therefore we're going to need B to be 4 of them. And because D has twice the chance of being picked as C, then we're going to need 2 Ds compared to 1 C. So that would be the answer for that question. B is likely. Well, we've got over half the cards of B. D is twice the chance of picking C, so we've got 2 compared to 1, so twice as many Ds as we do Cs. So that means it's got twice as the chance of happening compared to C. Okay, so a quick reminder of the probability scale, how we can use some of those words, and then how we can think about filling in missing scenarios. It goes on and talks about another set of cards, and it wants us to write the numbers 2, 3 or 4. So when we're picking a card at random, 4 has the greatest chance of being picked, but is not certain. So if it's not going to be certain, then it can't be every one of these is a 4. And 2 and 3 have the same chance of being picked. Okay, so if 2 and 3 have the same chance of being picked, then we're going to need the same numbers of cards with number 2 and number 3 in it. And 4 has the greatest chance of being picked. Well, the rest of them will be 4s, because that means it's got more chance of being picked than a 2 or a 3. But 2 and 3, having the same number of cards, have got an equal chance of being picked, the same chance of being picked. This question talks about a dual bar chart. So what we need to remember about a dual bar chart is that the bars are next to each other with a small gap, then next to each other with a small gap, next to each other. So just like a standard bar chart, where the bars have to have gaps between each bar, a dual bar chart, you're drawing the categories however many times you need them. In 2s in this case it's a dual bar chart, but there still needs to be a space, and then the next one, then a space, and then the next one. So it says 10 men choose fishing and 1 woman. So we look at the key, because all graphs like these need a key, or charts like these need a key. So 10 men, so that's going to mean we go up to 10 for men, and it says 1 woman, so we do 1 woman. And again, because they've done some shading and that, we need to make sure we're very clear. So we would have to make sure we've really done as much shading as we can. I mean, I'm going to do this quickly, but you guys should obviously make sure it's really well shaded. So it's obviously different to this one, which should have been hash lines just like that. And then for climbing, oh, I'm rushing. I've got to read carefully. 10 men choose fishing, so they've already done that. 1 woman chooses fishing, so they've already drawn that one. Okay, so we've got to look at this carefully. 12 men choose walking, so that walking needs to be bigger. So come on, you need to read carefully. I keep telling you guys to read questions carefully. And then 2 more men than women choose climbing. Okay, so we've got 12 men choose walking. We've got 30 men altogether. So we've got 10 there, 12 there, so that's 22, and that leaves 8 more men to be put onto the chart. So 8 men left. 1 woman chooses fishing, and 2 more men than women choose climbing. Okay, so if there's 8 men left for climbing, then it must be 6 women for climbing. Okay, so if there's 6 women climbing, there's 10 women altogether. 1 woman's already chosen fishing. 6 are going to choose climbing, so that's 7. Therefore, for walking, there'll be 3 of them. So just need to be careful that we read questions carefully. So again, we should try and make sure the key is followed by filling those in as carefully as we can. So for climbing, we decided there was 8 men left for climbing. And 6 women for climbing. Okay, so again, just be careful to put the right key on, and then this one should be pretty much shaded in fully, but I'm not going to have time to do that, so to shade it as best we can. Okay, so then we check. Alright, it's really important we check. So put the totals above each of the columns. So 10, 1, 12, 3, 8 and 6. Right, so for men we had 10 plus 12 plus 8, that equals 30. So that's how many the question said there were. It said there was 30 men. And for women we've got 1 plus 3 plus 6, which equals 10. And so for women they said there was 10 women, and we've checked and we've got 10 women plotted. Okay, so the dual bar chart again, we've recognised that we've left the gaps between each of the sections, 2 bars next to each other gap, 2 bars next to each other gap, and so on. So that should give us full marks for that question. And then the question goes on and talks about 38, that's important. So 38 children choose a sport. For each sport, a minimum of 1 adult for every 8 children is needed. Work out the minimum number of adults needed in total. So it's 1 adult for every 8 children. Okay, so if we need 1 adult for every 8 children, and there's 38 children, for each sport, again we've got to read carefully. Okay, so 24 is 3 times 8, so that's going to need 3 adults. 10, well, it's 1 times 8 with a remainder of 2, but you're going to need an adult for those 2 children as well, because it's 1 adult for every 8 children. So that means for hockey we're going to need 2 adults. And for tennis, you can't have half an adult, because 4 children would suggest half an adult. So the nearest whole number of adults would be 1. So in total we're going to need 6 adults. Okay, so it's a case of looking for multiples of 8, because it's telling you to do 1 adult for every 8 children, and then once you know how many 8s are involved, then you can work out the number of adults, and if you've got spare children, then you need an adult to take care of those spare children. And that's how that question could be done. This question goes on and talks about Jack working, and he's getting £10.50 per hour. It says work out his pay for 35 hours. Well, because it's a start question, we would normally have to fill in full workings out. We won't get start questions in 2017, but again it's always a good habit to write out full workings for every question. So because it's 35 hours, £10.50 per hour, then we're going to be doing 35 times £10.50, and it's calculator paper, so 35 times £10.50 equals 367.5. Please remember that on the calculator papers, and because this is about money, your answers must be in proper money context. So you wouldn't say £367.5, you'd say 367.50p, so it's £367.50. So it's really important you put the extra 0 on that the calculator doesn't when you're dealing with money questions. So for money, you've got to take care. The question goes on and talks about on Saturday his pay per hour is £5.20 more. So how much is he paid for 4 hours on a Saturday? So for each hour he gets £10.50 plus £5.25, which is going to be £15.75. And he's doing 4 hours, so it'll be 4 times £15.75. So again, just calculate a paper. So 4 times £15.75, £63 exactly. Okay. You would get away with just writing 63 because it's a whole number of pounds, but again it's a good habit to remember that money should have 2 digits after the decimal point, so if we always write it, then there's a chance we'll remember to do it in the exams. Okay, so that's that question sorted, and then we've got to move on, and another week he works 20 hours as normal and works on Saturday. His total pay is £372. How many hours does he work on Saturday? Okay, so we need to remind ourselves then. So normal pay was £10.50. Saturday pay was £15.75. Okay, so let's see how much you will get for the 28 hours of normal pay. So 28 times £10.50. So 28 times £10.50. So £294. Again, we're showing all our workings, being really clear what we're doing. So that's the normal pay. So what's left for Saturday? Well, that's going to be the £372.75. Take away the £294. This will be what he gets paid for Saturday. So 372.75. Take away 294. So £78.75. So that's how much he gets paid. He's getting paid £15.75 an hour. The question wants to know how many hours he worked, so we'll need to divide the £78.75 by the hourly pay to work out the number of hours. So left that on the calculator, so divide that by £15.75, and we find that he gets 5 hours. So the answer to that question will be 5 hours. Okay, so that's a question where it involves thinking through money and starting to sort out how you can work it through by seeing what was left to pay for Saturday and then dividing that by the hourly pay to get the number of hours. Okay, so the questions go on. And the question now talks about a shape on a centimetre grid, so it's really important that we recognise this as telling us it's a centimetre grid, which means that each of these squares then has an area equal to 1 square centimetre. And if you remember, 1 square centimetre we write as cm with a little 2 because we've multiplied a centimetre by a centimetre. Okay, so it says work out the area of the shape. So literally we can just count up how many squares we've got as it's on a squared grid. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the answer is going to be 16, and it says state the units of your answer. So we've just recognised that this is about square centimetres because it's about area, and therefore we're going to write 16 square centimetres. Okay, so the question then goes on and talks about tick any statements that are true for the shape in part A. Alright, so it says the shape covers less than 1/3 of the grid. Okay, so we need to obviously know how many squares there are in total for this grid then. So 1, 2, 3, 4, 5, 6, 7, 8 across. And 1, 2, 3, 4, 5, 6 up the side. So total number of squares equals 8 times 6, so equals 48. Okay, so the question says the shape covers less than 1/3. Well, what we need to realise, if we want 1/3, we divide by 3, and if we do 48 divided by 3 on our calculators, we get 16. So 1/3 is going to be 48 divided by 3. Find a third of anything, you always divide by 3. 16 squares, and it says the shape covers less than 1/3. Well, it says tick any statements that are true. Well, that one's not true. The shape covers exactly 1/3 of the grid. Well, yep, it does. 16 square centimetres, 16 squares is a third. The shape covers more than 1/3 of the grid. No. The shape covers less than 1/2 of the grid. Well, a half of the grid would be 48 divided by 2, which equals 24 squares. And the shape covers less than 1/2. Well, yeah, it's only 16 of them. The shape covers exactly. No. The shape covers more. No. So it's just those two that we're going to be ticking for this particular question, recognising how to work out halves and thirds. A third divided by 3, and a half divided by 2. Okay. So this grid is showing a rectangle, and it says draw a different rectangle with the same perimeter and a smaller area. Okay, so the first thing we've got to do is work out the perimeter of this shape. So the perimeter is add all the lengths, add all the edge lengths together. So we go around the shape in this case because the edges are on the outside of the shape. So we've got 1, 2, 3, 4, 5 that way, 2 that way, rectangle, so opposites the same, and so forth. So the perimeter is going to equal 5 plus 5 is 10, plus 2 and 2 is 14, so 14 centimetres. So we need a shape that has a same perimeter, so in other words 14, but it has to have a smaller area. Well, what we've got to realise for this rectangle here is it has an area of 5 times 2, or we could just count the squares because it's on a squared grid. So it has an area of 10 square centimetres. Okay, so we've got to make sure this shape that we do has the same perimeter of 14 but has less squares covered. Well, sketch a shape, think about what the perimeter would be. Okay, so this one was 5, so let's try 6. So that means that's 6 and 6, so that'd be 12 altogether so far. That leaves me 2, so that'd be 1 and 1, and that would cover 6 squares. So that would be less, wouldn't it? So basically they're expecting us to draw a shape. Doesn't matter, we could have had other ones, but this particular one will work. 1, 2, 3, 4, 5, 6. And again, because your exams are photocopied nowadays, guys, it's better you go over in pen when you're confident you got the right answer and shade it in just to make sure it's really clear what you want. Okay, and then show the examiners you've thought through what the process is. So 6 plus 6 plus 1 plus 1 is equal to 14 centimetres, and the area is equal to 6 square centimetres. So in other words, it has an area that is smaller, which is what the question wanted, but it has the same perimeter. Okay, so the next question talks about somebody being paid £20,000 a year. Remember, we say this is 20,000. Whole numbers, if we count the digits, 1, 2, 3, we get a comma. That is our thousands comma. So it's telling us that we've got £20,000 a year. He saves 3/8 of this amount. So how much does he save? So basically the question's saying we want 3/8 of 20,000. To find 1/8, we divide by 8. So we're going to do 20,000 divided by 8. So calculator paper again. So 20,000 divided by 8 equals £2,500. Because we want 3/8, then we times by 3. So times by 3, we get £7,500. So the answer here will be £7,500. Okay, so that's one way of doing that. Most calculators nowadays have a fraction key on them, so we could have just done 3/8 times 20,000. So on your calculators you'll find keys that have things like A, B, C on them, or it might just look like a box on top of a box, depends on whether you have Casio type calculators. But certainly learn how to use the fraction key because it's quite useful. So on this particular calculator, press 3, press the fraction key, press 8, press the times key, 20,000, press equals 7,500. So it'll give me the same answer. So it's quite often useful to learn how to use your calculator effectively by remembering what the keys will do for you. So the fraction key is quite useful. The question goes on and talks about somebody else being paid £32,000 a year. It says the rent is 6,000. The question wants the rent as a percentage of her pay. So we notice the order of the words. It's the rent as a percentage of her pay. So it's one thing as something of another. So it's kind of shouting out to write a fraction first. So it's the rent as a percentage of her pay. Well, that's the fraction of her rent as pay. To turn any fraction into a percentage, we times by 100. So again, we put that in our calculator. So 6,000, press our fraction key, over 32,000 equals, and then we times by 100. So because it's given me as a fraction, I press the fraction key again, it changes it into a decimal, so 18.75. So 18.75. Okay, so when it wants one number as a percentage of another, the easiest way to deal with those is to write a fraction first with the two numbers involved, and then times that fraction by 100 will give you the percentage. Remember why that works, guys, is because the 100 is representing the whole shape, or the whole thing, which is the full fraction 1 over 1, and this is part of the shape, so part of it's a fraction. So we do a fraction of 100. Okay, so this question goes on and talks about a trapezium. So we should remember that a trapezium is a four-sided shape with one pair of parallel sides. And it's asking us to work with centimetres, and it wants you to work out the total length of the sides when x is 2.5. Okay, so what we need to remember is that numbers next to letters, the number's called a coefficient technically, but the number next to the letter is telling you to multiply. So for this side length it's going to be 2 times 2.5, which would be 5. For this one it's already 2.5 because it's just an x. For this one it's 5 times 2.5, which is going to be 12.5. And for this one it's 4 times 2.5, which would be 10. So all we've done is we've replaced x with the value that we've been told to use, so we've substituted that value in, and then we've worked out the length of each of the sides. The question wanted the total length, so that just means we go around the side of the shape adding everything up. So we had 10 plus 2.5 plus 5 plus 12.5. And you could do that on the calculators, guys, but 12.5 and 2.5 is 15, plus 5 is 20, plus 10 is 30. Okay, so 30 centimetres. Just check that again. 12.5, 15, 20, 30. Okay, so that's how we can substitute values into expressions, recognising that numbers next to letters means that you're multiplying by the value of the letter, so 2 times 2.5 and so on. Okay, so this question goes on and talks about giving an answer in metres. We can see from the question the way it's been worded, we've got different units. So classic here, guys, anything that's got different units in any question that's got different units, quite often it's useful to change one of the units into the other. And again, most times it's best to change them into the smallest of the units and then turn it back into the big unit if you need to at the end. So here we're expected to remember that 1 kilometre is equal to 1,000 metres. K, remember, stands for kilo. A kilo of anything is 1,000 of them. Kilogram, 1,000 grams. Kilometre, 1,000 metres, and so on. So if I've got 10 kilometres, then 10 kilometres is going to be 10,000 metres. If I've got 1.5 kilometres, then that's going to be 1,500 metres. And if I've got 500 metres, then the question says you want to add them all together. So we're going to add all these together. So we've got 10,000, 11,500, 12,000. So the answer here will be 12,000 metres. How many 125 millilitre glasses can be filled from a 2 litre bottle of water? Well, again, we've got a question here with two different units. Milli is a thousandth, so it means there's going to be 1,000 of these in a litre. So again, it's remembering our conversions. So 1 litre is 1,000 millilitres, and 2 litres would be 2,000 millilitres. And the question wants to know how many, so it's going to be a share problem, a divide problem. So we're going to be doing 2,000 divided by 125, which will give us an answer of 16 glasses. Okay, so the answer there would be 16 glasses. Alright, we could check on the calculator if we want to, just to make sure that we did that calculation correctly. So 16. Okay, so this question is asking us to work with an imperial conversion. 5 miles is 8 kilometres. Now, in the 2017 exams onwards, they will give you this conversion in all questions, although it's useful to remember it, but they will actually give you any imperial metric conversions. So it wants you to show that 240 miles is approximately 380 kilometres. So we got miles, and we got kilometres, and we got 8. They want to know 240 miles, and the question is, what's that? Well, you've got lots of ways of trying to do this question, guys. You could say, well, right, fine. Well, how many 5s are there going to be in 240? And I'll do the same to there. I could say, how do I get 5 to become 8? And do the same to 240. Either way, you're going to get the same answer. So to find out how many 5s I need to get to 240, I'm going to have to share the 240 by 5. And that means I'm going to have to times this one also by 240, share by 5. So 240 divided by 5 is 48, times that by 8 is 384. So we get an answer of 384 kilometres. And that's what the question wanted, because it is approximately 380 kilometres, which is how the question was working. So it's about recognising the proportion, the ratio that 5 to 240 had to multiply by 48. That's what gave you the 48, and then we're going to do the same here, times by 48. This question talks about points plotted on a grid, and it wants us to write down the coordinates of some points. So the really important thing to remember about coordinates is that they always have a x value and a y value. So in other words, you've gone along the corridor to get the x value, and then you've gone up to wherever you need to, or down to wherever you need to get to the actual point on the y-axis. So when we want the coordinates of A, then we've got to ask ourselves, where do we move to along the x-axis? Well, we move to -1, so that means we're going to have to go to -1, but then we came down to the equivalent y value of -3. So along and then down in this case, so -1 and then down 3. C is a point on the grid. It says that C are integers, so in other words we're looking for whole numbers. It's telling you that to get from A to C it's 3 centimetres, and to get from B to C it's 6 centimetres. So 3 centimetres away, if it's whole numbers, then we could have gone to there, but then that wouldn't be exactly 6. Could have gone to there, so this is looking likely. So that's 1, 2, 3 centimetres, and then BC, okay, if that is C, then BC is at 6. 1, 2, 3, 4, 5, 6. Okay, so C will have to be there then. So it says write down the coordinates of C. So the coordinates are 2, because we have to go 2 across, and then down to -3. So 2, -3. So again, we just use the logic, because they told us that they're integers. We need to remember that integers mean whole numbers. So we had to go in whole numbers. So 3 that way wouldn't give us 6 to be. 3 that way was way over 6. 3 that way, 6 up there. It seems to work. Okay, so that was the answer to that question. Okay, so this question talks about working out the size of an angle. We look at the shape and we can see that it's about a triangle, and what we need to remember about triangles are the angles inside a triangle add up to 180 degrees. So we need that fact. So basically this question is saying we've got 180, we're going to take away the 51 degrees, we're going to take away 90 degrees, because again we need to remember that that is a right angle symbol, so that's going to be 90 degrees, and then when we do that calculation we'll see what's left for x. So 180, take away the 51, take away the 90, gives us 39, so that's going to be 39 degrees. Okay, so the next question talks about working out the size of the angle y here. And we can look at this shape and we can see that we've got a four-sided shape ABCD, a quadrilateral. So angles in a quadrilateral add up to 360 degrees, and we can see here that we've got 2 angles that meet at a point, and then we need to remember that's going to be 180 degrees as well. Angles that meet at a point add up to 180. So if we work out this one first by doing the 360, subtract all the other angles, will leave us what's left. So we're going to subtract 75, 130 and 43. So 360, take away 75, take away 130, take away 43 equals so 112. So that's going to be 112 degrees. Do a check backwards. So 2 plus 3 is 5, plus that is 10. Yep, so it needs to work. And then to get the y, we recognise that we can do 180, take away the 112 degrees, because angles that meet at a point in a straight line add up to 180. Okay, so 68 degrees. Okay, so that's a quick reminder. They do like angle questions in your exams, guys, on the foundation level and the higher level, so make sure you're practicing your rules of angles and shapes. As you can see, we're going on to another question involving an angle inside shapes. They've given us a clue. It's an isosceles triangle. Again, you should recognise an isosceles triangle because of these two dashes through the sides of the triangle, telling you that they're of equal length. And what we need to remember about an isosceles triangle is that the base angles in an isosceles triangle are equal. So base angles in an isosceles triangle are equal. Just be careful though, because base doesn't always mean at the bottom, because the isosceles triangle could be this way round, and the base angles would be there, and it would be these two angles which are the same. They're at the end of the two lines that have the same length. So just got to remember it's about the isosceles triangle. Two angles are going to be identical. They're at the end of the straight lines, and we call them base angles in an isosceles triangle are equal. So it wants to work out the size of angle x, so that's this one around here. So what we can recognise is that here we have angles around a point. So angles around a point add to 360 degrees. We've already said a minute ago on one of the previous parts of this question that angles in a triangle add up to 180. So basically, if we do 180, take away 50 degrees, that's going to be these two angles, and then we halve that. That tells us that that must be 65 degrees and that must be 65 degrees. Advice that I give quite often, guys, is if you've got numbers being created, add them to the picture, because quite often that'll help you to see what you can do next. So when you create new information, put it onto the picture to help you see if you can get the answer they actually wanted. So we can see here then that we have that angles around a point. They add up to 360. We already know this bit is 65, so we'll need to do a subtraction to find the missing bit. So we need to be doing 360, take away the 65, and that will give us 295 degrees for x. Okay, so this question talks about simplify. Simplify, write shorter, write less, and we can only do this with algebraic terms when they are similar, so or when we're multiplying. So here we've got to think about, we've got 5 a's and we've got take away 2 a's. It's always important to remember to keep the operation that's in front of the term. Now, although there isn't an operation in front of this one, technically we've always got to remember there's a plus sign in front of there, but we just don't write it as mathematicians. So what we've got then, we've got 5 a's take away 2 a's, so that gives us 3 a's, and then we've got 4 b's positive plus another b makes 5b. So again, it's about recognising what we're doing here. We're doing 5 a's take away 2 a's, and we're doing 4 b's which are positive plus plus another b, which will add together because a b is one of them. So 4 b's plus another one makes 5 b's. Okay, so that'll be 3a plus 5b. This question goes on and talks about solving. So solving means find the value of x. That'll make this true. There are lots of ways of doing these kind of questions. You could cover that up and say to yourself, well, what do I subtract 7 from to give me 9? And then we'd recognise from our inverse operations that that must be 16. Or we can go through the process of moving terms from one side of the equals, this is the left hand side, to the other side, the right hand side, by doing the opposite operations. So negative 7 plus 7 would make 0 to leave us with 4x's. 9 plus 7 would make 16. So we now know that 4x is worth 16. So in other words, we're talking about something in the 4 times table is 16. Well, if we want x, then we're going to have to share 16 by 4. That was 4 times. So the opposite of timesing is dividing. So we're going to do 16 shared by 4 and get an answer of 4. And we check that 4 times 4 is 16. Take away 7 is 9. Okay, so this question talks about having a menu. We've got a choice of a starter and a main course. Somebody wants to have one starter and one main course. We've got to list all the different choices she can have. Well, rather than write out all these words, the beauty of algebra is that we can shorten them down. So we'll call that S, call that M, call that P, call that C, and call that B. Just makes the writing a little bit easier to be working about. He wants to list all the different choices which she could have. So if we have the heading starter and main, then she could have soup with curry, she could have soup with burger, she could have melon with curry, she could have melon with burger, she could have pate with curry, and then she could have pate with burger. And that would be all the different combinations that she could have. Just doing it in a kind of a logical way, using letters to help us not write as much as we needed to. So we're clear that the choices you could have are those. This question wants you to do 8.2 cubed, and what we've got to remember in our calculators is there's a power key. So on this particular calculator it's there, it's y with a little x above it, so y to the power of something. On some calculators it might look like x with a little box above it. There's lots of different keys, so do learn what your power key is on your calculator. So on this one then I'll be pressing 8.2, I'll press my power key, I'll tell it I want to do power 3 and press equals. Now my recommendation is on calculator questions, always write down every digit on the calculator. Then ask yourself what would be sensible to write down as your final answer. In this question they've already told you what is going to be sensible. They want one decimal place, so it's going to be 551.4. Now if you remember, one decimal place means one digit after the decimal point, and we imagine basically cutting the number there, and we ask ourselves, is the following digit 5 or more? If it is, then the previous digit goes up by 1. The reason being, of course, is that this answer could have been 551.3, or it could have been 551.4. Halfway would have been 551.35. Well, the 6 is above that 5, so it's going to be nearer to the 4. So basically we're going nearer to the 4. This question says work out the value of this. Again, my recommendation would be is to do each part separately if you've got a calculator like mine. If you've got one of the modern ones where you've got the fraction key that looks like that, then of course you can just press that and then put in what you see straight away. So on my calculator I do it step by step. So the square root of 6.76, press equals, and then I divide by 2.5, press equals, so 1.04. Okay, I mean, just remember guys, although there's lines here, sometimes you don't need to write anything. They're there just in case you want to show your method and write down what's going on. Okay, so this question talks about two fair spinners, so we've got to assume that everything's equally likely to happen. There's no bias going on. It says put a letter on each of the section of this spinner, so the probability of landing on each letter is the same for each spinner. Okay, so we've got to work out the probabilities for these. Well, the language we use for probability is capital P, in the bracket is the outcome we want, so we want the probability of A, and there was 1, 2, 3, 4, 5, 6, 7, 8 sections, so our probability is going to be out of 8, and there was 2 A's, and that's going to be a quarter. And then we can think about the probability of B. 1, 2, 3, 4, so that was 4/8, which is a half. And then we can think about C. Well, C is the same as A. There's 2 sections there, 2 sections there, so the probability of C will be a quarter. Now we check how many sections we've got in this one. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 sections. So half of them need to be B's, according to this. So that means it's got to be B, 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 and B. So 1, 2, 3, 4, 5, 6 of them. So the probability of B here would be 6 out of 12, which is also a half. So that's done. We want these two to be the same, quarter. So there are 1, 2, 3, 4, 5, 6 sections left. So there must be 3 C's and 3 A's. And then we will do a check in our mind just to make sure that it's working. So the probability of picking an A on this spinner is 3 out of 12. And when we cancel that down and simplify it, we get a quarter. Remember, your calculators will do the simplifying for you. Press your fraction key and it simplifies down to 1/4. Excuse me. Okay, so this question goes on and talks about doing reflections, and it wants you to reflect in the x-axis. So a piece of tracing paper is a very useful piece of equipment for this type of question. So we'd get our tracing paper, trace over the shape, draw some of the mirror line, put a point on the mirror line so that we know that we're going to line it up, reflect our tracing paper over, line up the mirror line, and then we can see that the new shape has got to be here. So basically if we put dots down at each of the corners, the vertices, then we can recognise that that's where the new shape's got to go. So we then get our ruler and join that together to make sure that it has worked. Now if the examiners have not given you a piece of, the invigilators, the people who watch over your exams, have not given you a piece of tracing paper, you are entitled to ask for it. So make sure you get some tracing paper if it helps. You could also do reflections from counting. So if this is our mirror line, then this was 1 square away. So in our reflection it will be the same, 1 square away, measured at right angles of course. It's really important that you remember to measure your distances at right angles to the mirror line. This was 3 and this was 3 as well. So there are other ways of doing that, but I think tracing paper tends to make this a little bit easier to deal with. The question goes on and talks about B being an enlargement of A, and it wants you to work out the scale factor of enlargement. Lots of ways of thinking about this, but there is a little rule that says the scale factor is the new length divided by the old length in corresponding positions. So obviously we need to be in the same position. So when we look at this shape, probably the easiest thing to do is we recognise that this one was 1 and on this new shape it was 3. So the scale factor would tell us to do the new length of 3 divided by the old length of 1. We knew this was the new shape because it says shape B is an enlargement of A. So in other words, A was the original shape and B is the new shape. So this was the original, the old, and this was the new. So that's how we can think about scale factors. So 3 divided by 1 is 3, so the scale factor will be 3. Remember, not times, you don't put the times sign there. It is a scale factor, it's just telling you what you do. So just a number for scale factors. Okay, so the question now goes on and talks about a stem and leaf diagram. It's given you the key, so remember it's important with stem and leaf diagrams we do have a key. So it's telling me that if I take all of these numbers, these are the tens, and if I take the 5s, the other side of the line, then these are the units. So to interpret this, then 4 and 6 means that that's technically 46. But we use a stem and leaf diagram to write less and just show the numbers in a neater format. So it's saying he's played 15 hockey matches, and this is the time that he played in each match. Okay. The table shows information about the number of goals scored. So it says work out the number of goals that Sam scored in the 15 matches. Okay, so the number of minutes Sam played in a match, average number of goals he scored. Well, if he played less than 30, then he scored 0. So for these then, he scored 0. So if we put after each of these how many goals he scored, it will help us do the calculation. 30 to 45, he scored 1 on average. So all of these are going to be worth 1. up to 45. So this was representing 46, so that's going to be more than 45. So basically they're now saying that everything from here onwards, on average, he scored 2 goals. Okay, so it says work out the number of goals that he scored in the 15 matches. Well, if we do it from the table, it might be easier. So here he scored 0, so this is the total. So here he scored 0, there he scored 3, here he scored 1, 3, 5, 7, and here he scored 2, 4, 6, 8, 10, 12. So this is just typically on average what happened. So then we add these up, so 10, 12, 22. So when it says work out the number of goals that Sam scored, we'd put on the answer line 22. Now again, don't worry that there's loads of space here. If you want to do your workings around the pictures or the tables, you are totally entitled to, and the examiners who mark your exams have to look at the whole page to see where you've done any working that might get credit. This question, it was much easier to work around the table than to try and carry numbers over here, and then you can just work out your totals. Okay, so we've got a question here that is talking about booking a holiday. It wants you to book a holiday for 1 adult and 1 child. It's giving you some costs and it's telling you there's a special offer, so we need to make sure we're taking note of those when we're actually thinking of the answer. She has £1,000, so does she have enough money to book using the special offer? Okay, so it talks about 15% off, so we're going to work out the total cost first. So that's going to be 720 plus 430. So we've got 1150. So, and then there's 15% off. So 10% of 1150 is going to be 115. 5% is going to be a half of that. So £57.50. So if we add that to the 115, then we find we get £172.50 discount because it's an offer. So we're basically going to do the 1150 we've worked out it would have cost before the discount, take away the discount, see what that comes to. So 1150 take away the discount is £977.50. So, does she have enough money? Yes, she does, because she has £1,000, and that's more than £977.50. Another way of doing this question, though, it's a calculator paper. So we could have done the 2 numbers added together for the cost of the adult and the child. We then could have times that by 0.85. Now, 100% would have been the total cost less the 15% discount, leaves you with 85% to pay. 85% is the same as 0.85. This is called a percentage multiplier. So we could have done it this way to check that we was going to get the right answer both ways. So that was the total cost without the discount, times that by 0.85, then we get the £977.50, which we had using the other method. So again, sometimes useful to do a quick check by doing an alternative method just to see that you get the same answer. Okay. The question talks about an exchange rate. So it's saying £1 is going to get you 1.25 euros. That would be good if you could at the moment with the way Brexit is going, but still. So changes £800 before he goes on holiday. Okay, so the first thing we're going to do is work out how many euros he got. So for every pound he got 1.25, so for £800 he's going to get 1,000, so that equals 1,000 euros. So that's what £800 is worth. He spends 895 euros, so euros left must be 1,000 to take away the 895, so that's going to be 105. He changes the euros that he has left back into pounds, and the exchange rate is now. That's usually the con that people do with you to get more money back. They'll not give you the same rate back. So it's 140 euros per pound. So we've got 105 euros left. For every 1.4 of those euros, we're going to get a pound back. So we have to do a share divide to make that happen. So 105 divided by 1.4 equals 75. So we're going to get 75 pounds back. Okay, so that kind of question then, we're using the conversion that they tell us. So every pound got 1.25 euros, so 800 times that. Work out how many euros were left, then divide by the number of euros per pound, and that gave us how many pounds we'll get for that question. Okay, so here we've got a recipe. It's a recipe for 8 biscuits. The question wants an amount for 20 biscuits. So how much ingredients do we need for 20 biscuits? Lots of ways of doing this question. You could find for 1 biscuit and then times by 20. We could see how many 8s go into 20 and then times the recipe up. So there are lots of ways of doing this. With a calculator paper, it's probably easier to see how many 8s are in 20. So 20 divided by 8 is 2.5. So we need 2 times all ingredients by 2.5. So for flour, we're going to do 75. Oops, not quite sure why I put this point there. 75 times 2.5. For sugar, we're going to do 50 times 2.5. For butter, we're going to do 40 times 2.5. And for eggs, we're going to do 2 times 2.5. Okay, so 75 times 2.5, so 187.5. 50 times 2.5 is going to be 125. 40 times 2.5 is going to be 100, and 2 times 2.5 is going to be 5. Okay, so always useful again to do a check. So let's say we was going to do the flour in terms of what 1 biscuit needed. So 75 divided by 8 would tell us what 1 biscuit wanted. So 75 divided by 8 is, so 75 divided by 8 is, so 9.375 grams. And then if we times that by 20, that'll tell us how much we need for 20 biscuits. And so we needed 187.5, which is the same as what we got the other way. So, lots of ways of doing these recipe type questions. Find out what one of something is and then times up by how many they want, or just see how many of the recipes go into the new amount. So, lots of ways of doing it. We've been given a formula, and it's asking us to use the formula. So we need to recognise that each of these letters has a meaning. So C is represented in the degrees Celsius and F is represented in degrees Fahrenheit. He wants to convert 28 degrees Celsius into Fahrenheit. So they're telling us then that C is going to be worth 28. So we follow the formula. So the formula says to get the Fahrenheit, we do 9/5 times 28, and then we add on 32. Alright, so we've got a fraction key on our calculators, so 9/5, so press 9 and then 5 for the fraction key, equals, times that by the 28, equals, and then add on the 32, equals. It's in a fraction, so press the fraction key again to get it back, so 82.4. So you've got fraction keys in your calculators, guys, so when it's a calculator paper, use them. And for most calculators, you've either got something that looks like that, or something that looks like that, or something that looks like that. Lots of different types of keys on calculators. Learn your fraction key because it's very useful to you. Okay, so the questions go on and talks about the nth term of a sequence is this. So basically n is telling us our term number. So we've got to remember that n is the term number, in other words where you are in the sequence. So if we had the simple sequence 2, 4, 6, this is the third term, so n would be worth 3. It says work out the first 3 terms of the sequence, so n will be 1 for the first term, so we do 6 take away 2 times 1, For the second term, n will be 2, so we'll do 6 take away 2 times 2. And for the third term, n will be 3, so we'll do 6 take away 2 times 3. So we can see that 6 take away 2 times 1, well, BidMath says you do 2 times 1 first. As it's a calculator paper, recommend do all your calculations on the calculator because it will do the BidMath for you. Okay, so 4 is the first term, 2 times 2 is 4, taken away from 6 is 2, 2 times 3 is 6, taken away from 6 is 0. Okay, so that's how that question could be done. And then it talks about a term-to-term rule for a different sequence. So we've got to multiply the previous term by 2 and then subtract 3. The third term of this sequence is 31. Work out the first term. Okay, so basically they're saying that you take the number, doesn't matter what it is, times by 2, and then you're going to subtract 3. So to go backwards, we would add 3 and share by 2, because this is telling me the third term. So when n is 1, 2 and 3, it's telling me the 31 is the third term. So I need to go back to the second term, so I need to reverse the rule. So we're going to do 31 plus 3 and then divide by 2. So that tells me the second term was going to be 17, and then I do the same again. I add 3 and then divide by 2, and then I get 10. So the answer for this would be 10. I could check by following the rule the normal way. So if the first term was 10, then I multiply that by 2, 20, subtract 3, 17. Multiply that by 2, 34, subtract 3, 31. So lots of ways of kind of thinking about that question, but it is about using the rules in reverse. The term-to-term rule is just telling you how you get from one term to the next term to the next term. Okay, so this question is talking about grouped data. Remember, it's important you interpret the data carefully. So this is telling me that 14 people had a pay between £5 and £15 per hour, 12 people between 15 and 25, and so on. Excuse me. Okay, so it talks about 40 people, hence the reason we've got a total here of 40. Which group contains the median? Well, the 40 people, I'm going to need the 21st person and I'm going to need the 20th person because I need to be halfway. There'll be 20 below there and there'll be 20 above there. So I need to find the 20th person. So up to here we have 14. Up to here we have 26. All we're doing, remember, is adding on how many we've got each time. And here we'd have the 37th person, the 39th, and then the 40th. So we need the 20th person. Well, that's going to be in here, because up to here we've only got 14. And then we need the 21st, which happens to be the same row. So which group contains the median? It's the second row, 15 to 25. It says work out an estimate of the mean pay. Well, we've got to remember there's a fairly simple idea about the mean. It's because it wants the mean pay per hour, then we'll need the total pay divided by the total number of people. To get the total pay, we'd need to know how much these 14 people earned, these 12 people earned, and everything else. The unfortunate thing is with grouped data, we don't know exactly what these 14 people earned, so we have to use what's called the midpoint of the interval. We have to make an estimate of how much each of these used, and we use the middle of the interval as a best estimate. Some might have earned a little bit less, some might have earned a little bit more, and by using the middle we kind of balance it out. So here we're going to do the midpoint times the pay. No, the frequency, sorry, because we want to know what it is per person. So the midpoint of this was 10. 5 plus 15 is 20, halved is 10, and then we're going to times that by 14 and get 140. Here we've got the middle is 20, add those two up and half it, you get 20, so we're going to do 20 times the 12 people in this row, so 240. Here, halfway between those is 30, and then we're going to times by the 11 and get 330. Here we've got 2 people earning 40, and here we've got 1 person earning 50. So this is telling me how many of these, estimating how much of these 14 people earn, how much of these 12 people earn, and we're using the estimate by using the middle of the interval. So we need the midpoint. And we can just add those up quickly on our calculator. So 140 plus 240 plus 330 plus 80 plus 50 equals, so 840 is the total. So if we go back to the basic idea then of what the mean is about, then the mean needs total pay. Well, we've found out that that's £840, and the total number of people that this table represents is 40. So we're going to end up doing 840 divided by 40 equals, so 21. So it's £21 per hour. So that would be our estimate of the mean pay per hour. And we look at that answer and we say to ourselves, does it make sense? And when we look at this, then we can see that 21 fits in the data. There's a lot more people earning less money than the large amounts, so we do expect it to be down here somewhere. So £21 per hour would be a reasonable check. If we'd have divided by 5 there, because there's 1, 2, 3, 4, 5 rows, which would have been a common error, then we'd have ended up with an answer of over £100, and therefore couldn't have been right, because the maximum pay per hour in the table is 55. So again, it's worth checking, does your answer make sense? Okay, so that's a quick run through of how to work with group data, finding the median and estimating the mean. Right, so this question talks about a cylinder, and it asks us to work out the volume. Well, lots of ways of thinking about this. You either remember the formula for the volume of a cylinder is the circle of the end face area times the length of the shape, or you remember that at the front of, well, in fact for 2017 you don't get the formulas, I'm afraid, guys, so you do have to remember them. The formula for the volume of a prism, because remember a cylinder is just a special prism, got a circle at that end, circle at that end, cut it anywhere along the length, you'll see the same circle, so it is a prism, and that's going to be the area of cross section, which in this case is a circle. That's cross section, means where you're cutting it, times the length. So either remember the formulas for each shape, or learn the standard formula for all prisms and then just think to yourself, well, the area of cross section is a circle, so I need the area of the circle times the length. Now, the reason why you write down all the formulas, guys, it's really important you do, is because then you can identify the numbers you need. So in the question they're telling you the radius of the base is 6, so the formula requires the radius to be 6, and the height is 15. Well, we can think of the height as the length of the shape, that the circle cuts through all the shape, so the length will be 15. It's a calculator paper, so hopefully you've learned by now where your pi key is, and you're going to times by 6 squared, so 6 and then your squared key, and then you're going to times by 15, and you're going to press equals. Now on your calculators it gives you a really long number, so we write all of that down to be safe. But in our answer we're going to write down a sensible degree of accuracy. So 1696.46 would be fine. Okay, so that's how that question could have been done. You either remember the formula for the volume of the prism and then go through each of the shapes that you need, or you remember for a cylinder it has its own formula, pi r squared times the height or times the length of the shape. Okay, so the question goes on and it talks about a conversion. You have to remember this conversion, I think, nowadays. So 1 litre is 1,000 cubic centimetres. A tank contains 45,000 cubic centimetres and it leaks at 0.75 litres per minute. Okay, so 0.75 litres times 1,000 is 750 cubic centimetres. Again, two different units, so a question with two different units, you need the same units. Okay, it's really important in questions that when you've got two different units, convert one to the other to make the question work nicer. So it's telling you that it leaks at a rate of 750 cubic centimetres per minute. So we're going to have to do 45,000 divide by the 750 to allow us to calculate how many minutes this is going to take. So 45,000 divided by 750 equals 60 minutes. So it's going to take 60 minutes to empty. Okay, so again, question involving two different units, convert one into the other, and they were nice in this question, they told you what the conversion was going to be, but do learn that conversion because in past questions they haven't given you it. So do the division, find the time. Okay, so a baker makes 130 loaves, 6 times as many white loaves as granary loaves, half as many brown loaves as white loaves. Okay, so we've got white loaves, we've got granary loaves, and we've got brown loaves. It seems to be implying by the way the question has been worded that this is a kind of a ratio problem. It's telling you things like 6 times as many and so forth. So 6 times as many white loaves as granary and half as many brown loaves as white loaves. Okay, so if I call the granary 1, 6 times as many white loaves as granary, half as many brown loaves as white loaves. Okay, so I'm considering what happens with if if I had 1 granary loaf, then I must have 6 white loaves and 3 brown loaves because it's got so many. Okay, so we're working in this ratio. It's telling us there's 130 loaves made altogether. So we know the total number of loaves is going to be equal to 130. Ratio problems like this, it becomes a share problem. So we've got multiples of 10, 6, 1 and 3. We need to keep the same ratio throughout the calculation, so they always need to be in the ratio of 6 of those to 1 of those to 3 of those. So we're working in multiples of 10. So if we do 6 plus 1 plus 3, then we know we're dealing with that. So if we do 130 divided by 10, then we've made 13 lots of each part. So basically we're going to multiply everything by 13. So 6 times 13, 60, 78, 13 of those, and 3 times 13 is 39. So we do a check. So we do 78 plus 13 plus 39, and 70, 80, 110, 122, 130. So our check worked. So the number of white loaves was 78, the number of brown loaves was 39, and the number of granary loaves was 13. Okay, so again it's a case of looking at a question, thinking through what kind of maths can we use to help us solve this. The way it's been worded, it's a proportion ratio, 6 times as many. So if we said, right, what happens when we have 1 granary loaf, then we must have 6 white. If we have 6 white, because it was half as many brown, then 3. Recognise that we're working in multiples of 10 by adding up the ratio parts. Work out how many of those go into the total, and then that tells us we're dealing with 13 lots of each part. So 13 of those, 13 of those, 13 of those will build up to give us the answer. Okay, so last question. Let's have a look what it's talking about. So it's talking about a rectangle, so recognise straight away, add information onto pictures to help you see what's going on. And it says 6 of these rectangles are joined to make this shape, so we can add on the fact that that's 5x, 5x, x, 5x, x, 5x, 5x, x, 5x, and x. Okay, so again with questions like this, add on every bit of information you can. It's saying that the area of the white rectangle is, work out the area of one shaded rectangle. Okay, so if we know that's x, then we know this bit is 4x, and if we know that's x, then we know that this bit is 4x, and we already know that that's 5x. Okay, so what have we got then? We've got a white rectangle because they're telling us what the area of the white rectangle is. So the white area is equal to, well, in terms of x's, it's 4x and 4x, which is 8x, and we're timesing by the width here of 5x. So it's 8x times 5x, 8 times 5 is 40, x times x is x squared. So the question's telling me that 40 times the x squared value is going to equal 1440. So x squared is going to equal 1440 divided by 40. If I know what 40 of them are, share by 40 will tell me what one of them is. So 1440 divided by 40 is 36. And to get the value of x, I can then square root. Opposite squaring is square rooting. So the square root of 36. Now there's two answers for the square root of 36, of course, 6 and negative 6, but we can't have a negative length, so we're only going to deal with a positive answer of 6. So that's what that is. So that means I can now go back to the original rectangle. If I know that x is worth 6, then that means that that is 6, and 5 times 6 is 30. So that's 30 centimetres, that's 6 centimetres. No, it's centimetres because the question was talking about square centimetres. And to work out the area, I've got to do 30 times 6, so 180 square centimetres. The question says it wants one shaded rectangle, so we've got the answer for one shaded rectangle. Okay, so the answer there will be 180 square centimetres. Alright, so again, the advice with this kind of question is that you should add on information to the picture to see what's going on. Put that information on this picture, then we can see quite clearly how to work with x's. Recognise key things about the question. The question told us it was talking about the area, so we can work out the area of this white rectangle in terms of x, and then we can solve that. So we can then solve that for x. Once we know the value of x, so we knew that x was the square root of 36, so x was worth 6, then we go back into the picture to get the actual answer. Okay, so hopefully that's useful.